I'm here until all our classes leave for the night. So if you ever have any questions about enrollment, important dates, getting in contact with the department or something, you can always stop by there and I'll be there to answer your question. I'm going to run through some base information real quick. It's mostly emergency procedures. So if you've been on base before, if you've taken classes with us, you'll probably know all of this. For fire drills, or if the fire alarm goes off, you would evacuate up the closest staircase, which since we're down at this end of the building, would be just down the hall past the elevator. You go up there to the parking lot. In case of a fire drill, they ask you to remain in the parking lot until they give the all clear, and then you can leave or return to the building. If the shelter-in-place alarm goes off, you would again evacuate up the closest staircase into one of our upstairs rooms. They are all designated shelter-in-place shelters, and they will have information on the bulletin board for what you do in case of the shelter-in-place alarm going off. If there's a tornado drill or an actual tornado, you're already down in the basement, so you've got step one there. They ask that you shelter in the hallways. You exit out to the hallway, have a seat in any of the chairs lining it until you get the all clear for the drill. If the hallway is full, you can also shelter in your classroom for a tornado. Active shooter drill is a little more complicated. They generally don't do those in the afternoon or the evening, so you probably won't have to worry about it, but I will run through the instructions anyway. So if there's an active shooter drill, you would lock your classroom door, which you can do using this button right here on the side. Lock and unlock it. Lock the door, shut the door, turn off all the lights, and shelter against this far wall here. In case of a drill, you don't let anyone in the room, no matter what they say. If they try the door handle, you just stay silent and wait until they get the all clear over the intercom. And again, you probably won't have to do an active shooter drill, and if they let us know they're doing that, we will forewarn you in advance. So, class cancellation policy. Who here has the Grizzly Safe app installed? All right. If you do have a phone, Apple or Android, it works on both. You can install that for free. That is the #1 way we contact students about school closings due to inclement weather like snow, ice, anything like that. If you signed up for Bears Alerts, we'll also text you and leave you a voicemail. But I know the caller says the app is the #1 way to make sure you're notified about school closures. Few quick things about driving on base. Make sure you observe all speed limits. It is 30 miles per hour throughout the entire base unless otherwise posted, 15 miles an hour if snow or ice are present. And they will generally let you know at the gate if the road conditions are bad and they've dropped the speed limit. Don't use your cell phone while you're driving. Don't text and drive. Preferably don't even have your phone out, have it put away, glove box or your purse. If they pull you over for texting and driving, you automatically lose the privilege of driving on base and you'll have to walk to class. And it's about 1.5 miles, so you don't want to do that. Follow all other parking laws, make sure you wear your seatbelt, stop fully at stop signs. If you're pulled over 3 times for traffic violations, again, you lose the privilege of driving on base. So really important, they're pretty strict about that. If you're out walking or driving at 5 p.m., that's when they retire the flag for the day. So they play the national anthem over the intercom speakers outside. If you're out walking or driving at that time, they ask if you're walking, you stop and stand in observation, a moment of silence. If you're driving, pull over your car and stop until the anthem is concluded. Since it's a 4:30 class, you probably won't be out and about at 5 p.m., but if you are, just have that knowledge in mind. We do allow food and drink in the classroom, just use discretion, don't make a mess. If you have any trash, there are no trash cans in the room, but there are trash cans all down the hallways. And finally, I will let you know about makeup testing. If you need to do makeup testing for a class, take a final for an online class, any sort of thing like that. We don't offer testing here on base. We do across the street at the service center. It's by appointment only at the moment due to COVID, but you can always stop by my office. I will get you our test administrator's contact information, and they can set that up for you. Oh, and then the library. You can use the library here. I think they do close at 5 o'clock, but if your Butler base has to get on base, that also gives you access to the library if you wanted to use that. And unless there are any questions, that's all I have for you. So I will let you get to class. Let me know if the Zoom gives you any issues, and we'll.
I'm sure it will. We'll be fine.
I think you've got it done. So thank you for your time.
Okay, thanks, Molly. All right. Hello, everybody. My name is David Jones, and I'll be starting off by. Does everybody have a computer? Okay, you might get that out, and you didn't bring one. Okay. Let me see if I can catch them out. Okay, we should have a computer in just a few minutes. All right, let's see. Okay, I'm gonna start off going over the syllabus quiz, which if you guys, I don't know if you've joined the class in Hawks yet. Let me come around and see if everybody's done that yet. I put that on the screen, but I'm sort of afraid to mess with that because we might lose sort of the thing there. So you're in. Okay. You just have to go into the Canvas and then click Hawks or click Models. Right?
And then you just leave it in this room when your class is over. There you go. You'll log in with your Butler username and password.
If you guys want to click on the syllabus quiz, I'm just going to go through that. You don't have to complete it right now, but I'm going to go over the questions that you guys will have to answer on that. You would have to put it in the vote.
You want us to start it, or?
You don't have to, but you can. I'm going to go through all the questions here in a minute. So if you can sort of listen to me while you're doing it, that's probably fine too. Right. Forgot password. To your brother. Well, I can help you with that. Okay, so I'm just going to get started on it and then go through some of the things that you'll need to know for the course. Well,
Mr. Jones,
yes.
I do have a question for you. Say, if I were to get my daughter picked up from school on Thursdays, what is the routine that I would have to go through if I were to come onto base?
You'd need to get a base pass. I don't know if you have that.
No, all I have is my Butler badge. That's all I've got.
You could show up. There's a visitor center. You could go in there, let them know about the class that's on base that you're taking, and they'll get you a base pass. I don't know how long that process will take. Sometimes it used to be a few days. I don't know if they've made it much faster recently.
Right.
But it's possible you could be ready to come on base next week.
Okay.
But the visitor center is right when you pull into Macomb.
Yeah. My brother-in-law is a tech sergeant on the base, so.
Oh, okay.
I just didn't know because they didn't tell me any of that information. They just said, have your Butler ID. And I'm like, okay. So, because I work in Valley Center, so I may be able to make it there maybe roughly 10 to 15 minutes late.
Okay, that's fine.
And that would be better than me not getting home until 5. So, I may be able to have somebody
and
pick
we were
her
talking
up.
about it earlier. It'll definitely be easier to learn the material if you're here because,
Right.
we'll have time to work and I can come around and see where you might be getting stuck and give you a little nudge in the right direction after that. Okay,
Right.
so I don't know if you can see the syllabus on your screen there.
Yep.
Oh, syllabus quiz rather. Okay, so I'm just gonna read these. If you want to open up the syllabus quiz and go through, your questions aren't going to be in the same order that mine are because they're kind of randomized, but hopefully you can remember what I said. Before the certify will open, I need to complete what percentage of problems in the practice mode? That's 65%. We'll go over 7.10 to start with. When you guys get into it, you'll see a practice mode and you'll also see a certify mode. Certify is going to be the homework, but that's grayed out until you've done the practice. 65% on the practice opens up the certify and then you can get into the homework. So 65 on the practice. In order to get an A, B, or C in this module course, I'm required to make 65% on the better on the module exam and 70% overall. So again, 65% for the module exam when we get to that, 70% overall, that's true. Module exam must be proctored, that's also true. I'm gonna be in the room with you while you're testing, just like a normal test would be. When I finish my module exam, I will not be able to see my percentage in Hawks until my instructor releases it. That's true. Sometimes people are a little disappointed by that. They do the test, they click submit, they don't see what they did. So it might be an hour or two later where you can log in and see how you did, because I go in and give partial credit. So your grade may initially be 75, but after the partial credit, it might be 90, depending on how much work you've shown. So won't be able to see your percentage. Which of the following items are included in my overall grade? Certifies, module exam, additional learning activities. All of those are a part of your overall grade. If I don't make a C or better in this module course, or if I score 65% on the module exam, I need to. So if you don't get 70% overall, don't make 65% on the test, then you'll need to redo at least the 5 weeks course that you took. Hopefully that doesn't happen. But you'll need to plan to re-enroll with an advisor, see an advisor immediately, talk to an instructor. Any of those would be reasonable things to do if you didn't pass. So all the other answers. Before a certified due date, how many times can I try to certify that lesson without penalty? Unlimited. When you go in for, say, 7.10, you'll have something like you'll have a heart with maybe the number 4 in it. That's the number of strikes that you can get. When that gets down to 0, you got no more strikes available. If you get something else wrong, then it's going to kick you back to practice and you'll have to start over for the certify part. But as long as you get the certify completed by the due date, you can do it unlimited amount of times. You still get 100. Minimum passing score in the module exam is 65%. If I make 64 or below, I will need to talk to my instructor about retaking the course. You have to get 65 on the module exam. Otherwise, it's redo, which is kind of a low bar. 65 is a D. If I don't like my score on the module exam and I think I can do better, I can retake it. No retakes on the module exam. If I need help understanding a concept, what can I do? This is one of those kind of common sense options. Math Lab, El Dorado, and Andover, which might be kind of a drive for some of you if you live in Wichita. There's Hawks videos in there, Hawks tutors. I'll usually spend about 20 minutes on the lesson and then we'll have time to work. So you'll have a good amount of time in class to let me know if there's anything you don't understand. So we have sort of built-in tutoring in the classroom, but any of those answers would work. When I finish my module exam, I will be able to see which problems I missed. So unfortunately, no, you won't be able to see which problems you missed on the module exam. There's a few rare occasions where there's exceptions to that, but generally, no, you can't see what you missed. If I make 65% or better on the module exam, which meets the minimum score requirement, is it possible that I will have to retake the course? So you get 65 or better on the module exam, But if your overall grade isn't 70%, then you would need to retake it. And the only way that would happen is if you turned in all your homework late, way late on every homework assignment. Maybe your average homework score was 50%, and then the 65 on the test wouldn't be enough to give you a 70 overall. So that rarely happens. Usually if somebody gets a 65% on the test, that's good enough for them to pass. At the module exam start time, if I have one or more assignments that are not certified, then I will need to talk to my instructor to retake the module course, since my grade will be an F. So we'll have several different homework assignments. When you come in on test day, all of those homework assignments have to be done in order to test. So if you're not ready to take the test at the start of class with your classmates, then you'll need to redo the 5 weeks. So make sure those homeworks are being completed on time. During the module exam, I can use no index card, no cell phone, no certified steps, but there is a formula sheet you can use. Partway into this course, my instructor will give a quiz. That's true. Every day we'll end the class with a quiz, real short, just one question over the material that we cover. You guys can confer with each other if you want. I generally try not to help on the exit questions. That's what I call them, the exit quiz. But we'll have a quiz every single day. If I certify a lesson after the due date, I will receive a late penalty. That's true. 710, 711, and then 8.5 are all due next Wednesday night. If you're not done Wednesday and you finish it on Thursday, each day is 10% off. So even on Thursday night, you could still get 90%, then 80, then 70. So there is a late penalty. Course syllabus is located in Canvas if you need to look at it. To have the best chance of success in this course, this is another one of those common sense. They give you a bunch of things. Spend an appropriate amount of time studying, finish the certifies, show detailed steps for each problem, use time wisely, ask instructor questions. All those are good uses of time. And then the last one, if I certify a lesson by the due date, even if I miss some problems within the allotted number of strikes. So you've got 4 strikes, you've used, let's say 2 of them, and in that heart, you've got 2. And then you get to done with the assignment, you'll get 100%, even though you had a couple strikes. So as long as you complete it, 100%. And if you're there at this point on your syllabus quiz, at the top left, it says submit assignment. I think it's going a little bit slower because it's doing the Zoom also at the same time. We'll go ahead and start with 7.10. Okay, solve the absolute value equation. And let me know if you guys can't read any of that. Let's see. Okay, solve the absolute value equation. Little bit of a concept. You've got the absolute value of x equals 5. X could be a few different things. Maybe you guys know absolute values a little bit. Absolute value is just the distance from 0. So x could be 5. The absolute value of 5 is equal to 5, since 5 is 5 away from 0. So x could be 5. There's also another number that's 5 away from 0. X could also be -5. 5 has an absolute value of 5. -5 has an absolute value of 5. So it could be either of those two things. X could be either of those. You won't see any that look exactly like that. The first example, the absolute value of 5x plus 2 equals 6. So I don't really have any way of blocking that out, but let me just erase that for a minute. So if you forget about the 5x plus 2 part just for a second, and you imagine maybe we've got an x in there, the absolute value of x equals 6. So x could be 6, or what else could x be? -6. It could be either of those. The thing inside is either 6 or -6. So you won't see any problems that look like that, but the same concept applies if we've got 5x plus 2. So this thing inside, just like with x, 5x plus 2 equals 6. The thing inside equals 6, or 5x plus 2 equals -6. Let me highlight those 6s. Okay, so the thing inside equal to 6, or it's equal to -6. And then you just have to go through your basic algebra steps. Hopefully you have a little bit of experience with that. One little note here, absolute value cannot be negative. So that has to do with the point where we've got the absolute value equal to something. Down here, it doesn't matter if it's negative because you're just saying, you're not talking about an absolute value, you're just talking about the thing inside. But up at the top, if we had the absolute value of 5x plus 2 equals -6, then you wouldn't do anything. We just say this is not possible. Absolute value can't be negative, no solution. But here it's equal to a positive, so we write that out and then solve. So subtract 2, just trying to get x by itself. Bring down the equals. We've got 5x on the left. 6 minus 2 is 4. Divide by 5 on both sides. And we're left with x equals 4/5. On the right, subtract 2. Bring the equals down. We've got 5x on the left. -6 minus 2, -8. Divide 5, and x equals -8/5. So you'll be given an option 1 solution, 2 solutions, no solution. Which one would we pick here? 2 solutions. Two solutions, and I think what it'll do is it'll bring up 2 boxes, and you'll put in 4/5, you'll put in -8/5. And then this one here at the bottom where no solution, that's if the absolute value equals a negative. No solution if absolute value equals a negative. Okay, number 2, absolute value of 2x plus 5 minus 1 equals 0. The only thing that's different about this one from the last one is we've got something else on the left side of the equals besides the absolute value. So we've got to get the absolute value by itself first. And I'll put exclamation mark on there because sometimes people don't do that. Sometimes what they'll do is they'll put the 5 and the -1 together. 5 minus 1 is 4, and then they go from there, but you don't want to do that. So first thing we're going to do is add 1 on both sides. We still have, if we bring down the equals, we still have the absolute value of 2x plus 5. And then on the right, we've got 1. Now, I just want to make sure you keep remembering this, that at this point, the absolute value can't be negative. Absolute value can't be negative. So as long as it's equal to 1, 1's not negative, so we'll just keep going. If it was equal to -1, we'd stop right there, click no solution, move on to the next problem. But just like before, whatever's inside, if you forget about the 2x plus 5, whatever's inside is either 1 or it's -1. All right, subtract 5. 1 minus 5 is -4. Divide 2. Make sure you guys let me know if we need to go a little bit slower on these algebra steps. So -4 divided by 2 is -2. On the right, subtract 5. Bring down the equals. We've got 2x. -1 minus 5 is -6. Divide 2. And we've got x equals -6 divided by 2 is -3. So again, we got 2 solutions. Put in both of those and good. And we've got plenty of time if there's any questions, you know, clarifications, anything like that. If you guys have anything you'd like to hear me explain twice.
Can you go back to that last one where the answer was a negative? Would that have been one solution rather than, or,
You talking about the -2 and the -3 here?
yes,
The answers can be negative.
okay.
That's fine. It's just at the top where we've got the absolute value. That's the only part we have to be careful about this. Okay. Yeah, in the practice part, I'd like to demo this, but I think there might be some complications with the Zoom thing. But in the practice, there's a little tutor button down at the bottom that you guys can always click, and it'll show you all the steps involved in it. Once you get into the certify, which is the actual homework, the tutor button isn't there. So you actually have to know it, otherwise you get strikes. Okay, so on this one, again, we want to get the absolute value by itself. So a couple things here. We got the 2 out front butted up against the absolute value. We've got the +10. We'll get rid of that first. 10 minus 10. Bring down the equals. So all we've got is the 2 and then the absolute value. Excuse me, 6 minus 10 is -4. And then we want to get rid of the 2. So we're going to divide 2. Anytime it's butted up against the absolute value symbol, we're going to divide to get rid of it. So 2's gone. And a lot of times people will just put x plus 8 on the next step, but we haven't gotten rid of the absolute value symbol. We've just gotten rid of 2. So we still have those bars on both sides. -4 divided by 2 is -2. Do we need to keep going on this one?
No.
Nope. absolute value can't be negative, no solution.
When we're doing these problems, I'm assuming you like us, do you get work from us? Like,
No, the
okay,
only work I'll collect is the quizzes that we do at the end of class. So just 1 or 2 problems maybe that it'll turn in.
I just checked, because I didn't know how far down you want us to go, but it's not.
No, I mean, if this was an exit question, this would be good enough. Just say no solution on that one. Okay. Number 4. Absolute value of negative 6x minus 7 is equal to 0. Absolute value can be 0, it just can't be negative. So generally, whatever's inside is equal to the thing on the other side, or it's equal to the opposite of the thing. But you would say negative 6x minus 7 is equal to 0, or negative 6 minus 7 is equal to negative 0, but negative 0 is not really a thing. So we can just get away with saying negative 6x minus 7 is equal to 0. We don't need to do the or negative 0. Bring down the equals. We got negative 6x equals 7. And then one thing to remember here, we're not just going to divide by 6. We've got to divide by negative 6. So divide by whatever the coefficient is. So negative 6 and negative 6 cancel. And we get x equals 7 over negative 6. And just one little note here. Put the minus on top. The software is not going to let you put it on the bottom, or it'll tell you it's not simplified, or it'll tell you, I don't think it'll tell you that it's incorrect, but it won't let you put the minus on bottom. You'll either need to move it in front of the fraction or up to the 7.
Can you put it outside as well?
Yeah, you can do negative and then set right out in front of that fraction bar and then 6 like that. How many solutions on this one? Just one. Yeah, the ones where it's equal to 0, those are the only ones where you'll just have one answer.
So, why would we still need the answer?
Yeah, you do still want to know what the answer is. The only reason you'd stop is if there's no answer. Okay, just a few more. Number 5, absolute value of negative 2x plus 3 is equal to the absolute value of negative 4x plus 2. This next thing I'm going to write, you don't necessarily have to write this down. It's kind of conceptual. You guys would agree with this, right? The absolute value of 5 is equal to the absolute value of 5. On the left, this is really, the absolute value of 5 is just 5, right? On the right side, the absolute value of 5 is also 5. So you're saying 5 is equal to 5. So this is true. Also, is there something else we could put inside that would also be true? Negative 5 would also be true. So if you've got absolute values on both sides, like we do on number 5, then either the numbers inside are the same, because that would be true, or they're exact opposites. Like I said, you don't have to write this down necessarily, but that's the ideal. Either it's the exact same thing inside, or they're exact opposites. Okay, so what that tells us here is that either this is exactly the same as this. So we'll write that out. Ooh, negative 2x plus 3 is equal to negative 4x plus 2, or negative 2x plus 3 is equal to, and over here I'm going to do the opposite. So instead of negative 4x, it's going to be positive 4x. Instead of positive 2, it's going to be negative 2. So the first side is exactly the same, just like we had 5 and 5. On the other side, 5 and essentially negative 5. So anytime you have two absolute values on either side, you can just work it out that way. I'll put a little divider in the middle. Okay, so we want to get the x's on the same side. You can add 4x. There's different ways to do it. But add 4x over there. Negative 4x plus 4x is 0. Add 4x underneath the negative 2x. On the right, we've just got 2. Subtract 3. 2x equals negative 1. Divide 2. On the right, you could subtract 4x. 4x minus 4x is gone. So we've got negative 6x plus 3 equals negative 2. Subtract 3. Negative 6x equals negative 5. What do we divide by here? Negative 6 on both sides. And we get x equals negative 5 over negative 6. Negative over negative is positive. So 2 answers. Okay, really one more example, and then I'll let you guys work for a bit. So absolute value of 5x over 2 plus 3 is equal to the absolute value of x over 4 plus 5. So absolute values on both sides. So the same concept as the last one. Either the things inside are exactly the same, 5 equals 5, or they're exact opposites. 5 equals negative 5. Ooh. So 5x over 2 plus 3 is equal to x over 4 plus 5. So here, negative x over 4 minus 5, just changing it. Opposite on the right. Okay, and there's different ways you could solve these, but one thing that we'll do with equations, you got an equal sign, equations with fractions, you can get rid of all the fractions if you multiply a common denominator. So we got 2 and 4. So you want to think of what something 2 and 4 both go into. So we're gonna multiply a common denominator by the tops, the numerators, to remove fractions. Multiply a common denominator by the tops to remove fractions. So in this case, we've got 2 and 4. Both of those go into 4. You could also use 8. You could also use 12, 16, anything that 2 and 4 both go into. Smaller numbers probably better. So I'm going to multiply 4 by each term. So times the fraction, times the 3, times the fraction, times the 5. Just the tops. And let me highlight that. Just by the tops. So 5x times 4 gives us 20x over 2. The 20 over 2, what's that going to reduce to? 10. So no fraction anymore. 3 times 4 is just 12. Here we've got x times 4, which is 4x over 4. There the 4s are going to cancel. And then the 5 times 4 is 20. So this second step, you could just do in your head. If you think of the 5 times 4 divided by 2, 20 over 2 is just 10x. The 4 over 4, those cancel. So you're just left with x plus 20. So you want to get the x's on the same side. I would subtract x. And that's a 1 in front of that x, so 10 minus 1. $20 on the right side. X equals 8 over 9. Okay, and then on the right side, same thing. You've got 5 times 4, 20 over 2. Maybe you can do the step in your head. 3 times 4. Over there, the 4s would cancel, so you're just left with negative x minus 20. What would I do next on that one? Yep, that's what I would do. You could also subtract 10x, however you want to do it. I usually like to move everything to the left. So plus x. So we've got 11x plus 12 equals negative 20. Subtract 12. We've got 11x on the left equals negative 32. Divide 11. So x equals negative 32 over 11 and 8/9. 2 solutions. Okay, and then just 2 really quick things I wanted to show you. Nothing new concept-wise. Okay. What the instructions will say on a few of them is put in standard form. And then we just have to get the absolute value by itself. So we'll get rid of the 6, we'll get rid of the 2, and then whatever we've got, that will be what you enter in. So for the standard form, we would subtract 6. Then we've got 2, and then y plus 1 equals -6. And then almost have the absolute value by itself. Got to divide 2. What's wrong with this here? Well, hang on a second. There's something else wrong before we get to that.
It's a no solution because it's a negative.
We'll have the absolute value around it.
That's it. Make sure when you do this dividing by 2 that you don't lose the absolute value symbols, because all we've gotten rid of is the 2. That's it. So with the absolute value symbol, this wouldn't be your typical solution, but this is the standard form solution that they want. Just the absolute value by itself. And then I think I heard a couple people say that absolute value is equal to a negative, no solution. So they'll have the standard form, they'll have sort of a part 1 and a part 2. Part 1, put it in standard form. Part 2, what's the solution? So to say solution, and there will be a yes and no. And on this one, you just click no, which is empty set, no solution. One other thing, if it says put answer in set notation, then all you're going to do with these answers that we had above, you know, the 8/9, the -32, you're just going to put squiggly lines around it. I don't know if that's this is 1G. So just like parentheses, but with the sort of squiggly part. So maybe you've got 8/9 and then -32/11, like that. That would be your set notation. If you've just got one answer, then just squiggly lines around the one answer. Okay. All right. So I'll let you guys work on that for a bit, and then we'll look at 7/11 and then 8.5 after that. On the computer?
Yeah, I think I'm gonna have to go upstairs because I have something text my phone and I don't have. Bars down here. I don't know if it's like in the basement.
Okay, we can try it.
Okay. Do you think it's the one base?
That was his basement.
Is it? Okay. So go upstairs.
I don't know why they added that. That's kind of a nuisance.
Yes.
Added security, but I don't know if we need it. Yeah,
Practice.
or the syllabus quiz, whichever one. You gotta drive safe, Trenda. Did you hear me?
Will do.
All right. We'll probably I'll let everybody work for 20 minutes. We'll see. Maybe they'll get done with the assignment in that time. We'll see. And then we'll look at the next lesson.
Okay. And is this kind of like a review of some of the things that we went over through pre-algebra and fundamentals?
Some of the stuff will be, although I don't think this was covered in a previous module.
I mean, some of it was, but it wasn't like together like it is. Because I was able to like, I don't know if you saw my mouth moving, but I'm like, yeah, this is that. This. So it's
Yeah,
like I knew.
What's that?
It's like I knew what it was. It's just like the steps are almost identical, but like that set notation was definitely new, except for like if you're graphing.
Yeah, the only thing I think that you're expected to know at this point is just the getting x by itself, you know, subtracting 6, dividing 2, that kind of stuff. But the rest of it is new, I think.
Okay. So I don't think I'll have too much of an issue doing that assignment when I get home.
All right. (7-11), I only have 5 examples. It's not, I don't think 7-11 will be complicated if you have notes. So I think it'll be all right. And then when we do 8-5, 8-5 is probably one of the simpler ones that you'll do in all of intermediate algebra.
Okay. Hopefully by the time that we get to 8.5, I'll be home, but I had to run to Viola, Kansas first and then head home. So
Okay.
my drive time's a little bit longer than normal. But I think I'm understanding it.
Okay. And you think you'll be here next Thursday?
I've got to try to work that out. What's the date on that?
26th.
26th. I am gonna see if my girlfriend can pick her up from school. I get out of work usually about 4 o'clock, depending on the buses, on if the buses get there on time. I would have to try to get on base before then to make sure that I can get the pass and stuff to get on base. If I get out at 4 from Valley Center, it's like what, a 15-20 minute drive depending on traffic. So I should be able to be there on time as long as I've got that pass.
Yeah.
But it's just I gotta watch my gas. I only have $100 left in my bank account, and I don't get paid till September 10th.
Another question, I'm sorry.
Mhm.
So, I don't remember where it's supposed to
Oh, okay. Modules.
be.
Oh, you might be. So, you might. You will have to, but if you don't have to have it, click on modules, and we'll just, if you haven't.
Oh, it's right here. That's it.
Mhm.
Okay, I remember now. So it's the bumper.
Yeah.
Okay.
Have you been through all this before?
Thank you.
You might, you forgot password. And I I noticed with another one of my classes that the reset emails.
Okay.
Super fast.
I think it's different with the email.
Did you have to go all the way outside for that text?
No, I just went all the way upstairs.
I'll be right back. Okay, so is it Danielle?
Yes.
All right, and then Diane? Lily? Jerry? That's me. Olivia? And Jennifer? Who's missing Diane? It's a house, I have to go outside every time I need to take a roll.
I work in a classified area across base where phones stay in our cars. So
Huh.
I have a question here. So I can already tell. I'm going to subtract 6, -6. Nothing there.
Right.
So
It will, anyway, for the standard form, they do want you to get the absolute value by itself. That's that. That's one of those last. ones.
Okay, so you still gotta put it.
Still got to put the whole thing out.
All right.
Even though it's not solution. That notability. It's a good. I used to use the Zoom whiteboard, but it is not very good at all.
I've had a bunch of different note-taking apps, and this is just my favorite.
Oh yeah, it's the best. I think.
I paid for like 4 different ones and I didn't like them.
Yeah, there's a bunch of videos on YouTube where people compare the different apps, and a lot of them they always come down notability.
Yeah, I really like this one. I can separate all my classes and have basically
yeah,
giant
yeah.
binder. It's basically just an online binder.
I wish they had that one out.
I know for my history class last semester, he gave us, mine was online, and he gave us like lecture notes. He basically shorthanded the whole section that we're doing. I could pull up Canvas on my iPad and share it to Notability.
And then just
And then the whole lecture that's come up, and I can edit on it.
That's not. Do you ever record the audio?
No, I've never tried that.
Yeah, I think there's a.
Yeah, there's the microphone right there, but I've never used it.
Yeah.
I'm gonna go back and listen first.
Yeah.
I take as many notes as possible, and if I mess it up, I will.
Can I ask a question? Standard form of equity. Like this.
Yeah.
Okay.
Yeah. Standard form is just the absolute value and then everything else, even if it's negative.
So I don't recall you going over this. It says, definition of absolute value, for example, into two equations of absolute value. So I got to that.
Oh, this is that thing too. So what happens at this step? Do I have my 4 and then what is here?
Before it.
The 4 is. You still have those. Okay, so from here, you say the thing inside is either 3 halves or the thing inside is negative 3 halves. So you have to make 2 equations, right?
Okay.
Y plus 1 is 3 halves and now that's.
Okay.
You gotta write the whole thing. Well, I mean, we'll do that, but you have to.
It'd be the whole thing?
Right.
Okay. Thank you. Without the.
Without the absolute value, yeah. I think that's what it's asking.
Yes. Sorry to be bothering.
No, keep bothering me. That's what this time is for.
With the same problem that said solution sets.
Uh-huh.
It says with these two for the solution.
When it's that set notation, that's just when you use the squiggly line.
Oh, so set notation and
Is it, on this one, it wants the ultimate answer. So is this is what you ended up with? This is that same problem?
yeah.
Yeah, you still have to work it out. So -1, -1. You gotta get y by itself.
So how would I?
Well, you just have to turn this. One's a nice one to work with because you need the same denominator. So you can make it, the denominator will have to be 2. So if you want it to still be 1, 2 over 2.
Okay.
So really what you got is 3 over 2 minus 2 over 2.
Okay.
And then it's negative 3 over 2. Yeah, I don't know if this will come up for everybody, but on some of them you might need to subtract like a 1 or something like that. If you're dealing with fractions, you've got to have the same denominator. So you need this to be a 2, and maybe you guys know that 1 you can represent with something over itself. So you make that -2 over 2 instead, and you get same denominator 2, but 3 minus 2 is 1. That might come up on some of yours. Okay, we'll start 7-11 here in about 5 minutes. Bless you. Okay, I think we'll go ahead and get started on 7.11. So inequalities, you got mouth open to the left or to the right. Mouth is always open towards the greater thing. Okay, so a couple other things. We'll do some graphing later on. For these ones, you'll use a parentheses on the graph. And that'll make more sense once we get to it. We also have these ones, the mouths with the line underneath it, greater than, less than, or equal to. On these ones, we'll use a bracket, which is basically like a parentheses, but with hard edges. Okay, so parentheses on those ones, brackets on these, which will just look like something like that. Okay, so number one, y minus 7, absolute value of that, is less than or equal to 4. Isolate absolute value. On this one, we don't have anything with the absolute value to get rid of, so we don't have to do anything on that step. But you will want to notice that the absolute value cannot be less than 0. So in other words, can't be negative. So if we had a less than 4, that's okay. Less than 0, not okay. Can't be less than 0. So keep that in mind. That would be a no solution kind of a situation.
Less than or equal to 0 would be okay.
Yeah, equal to, as long as it's one of those. I'm not going to spend a whole lot of time on the concept behind this, but basically y minus 7 less than or equal to 4. And we're going to do the same inequality symbol on the left side now. So we're taking it out of the inequality. And then on the other side, we're saying it's greater than or equal to negative 4. So we're using the same less than or equal to on both sides. 4 on the right, negative 4 on the left. And just to highlight, this is a compound inequality. We've got a left side, we've got a middle, and we've got a right side. We want to just get the y by itself. Y is in the middle, so we want to get it by itself in the middle. So add 7, and then we've got to add 7 to all those sides, the middle, the right, and the left side. So now in the middle, we've got y less than or equal to 4 plus 7 is 11. -4 plus 7 is 3. Okay. So just some stuff to emphasize here. This is called algebraic notation. You guys probably remember when you got to middle school or high school, maybe when they started doing algebra and they started throwing X's in there, letters and things like that. Algebraic notation has a letter, not just numbers. They'll also ask you for if they ask for interval notation. So if they just want algebraic notation, you can put that in and you're done. If they want interval notation, there's a couple of ways I could explain this, but I'm gonna go ahead and say it looks, let me know if you can't read my handwriting at any point, but looks like the graph. So if you made a little graph here, which in some cases you will need to do, we would have a 3 on there. We would have 11 on there. And at 3, we're saying that y is greater than or equal to. So the greater than or equal to ones, those are the brackets. If it was just, if it didn't have the or equal to part, we'd use the parentheses. But here we're going to use a bracket. Here we're going to use a bracket. And we're saying y is less than or equal to 11. So things less than 11. Y is greater than, since the mouth is open to the y as opposed to the 3. Y is greater than 3. So 4, 5, 6, all those would be highlighted. So this is what your graph would look like. Your interval notation, like I said, it looks just like the graph. You've got a bracket at 3, a comma, and then 11, and then your bracket. So it should look just like your graph. The leftmost thing, which is the bracket at 3, comma, which means 2, 11 with a bracket. Number 2, 3, and then absolute value x plus 3 plus 7 less than or equal to 13. Nothing new here, really. It's just the same, just a little bit more complicated process. 3, absolute value x plus 7 less than or equal to 13. What's the first thing we do? Subtract 7. So that's gone. We got 3, absolute value x plus 7 less than or equal to, what's that going to be, 6. Divide 3. Make sure you don't lose your absolute value. The only thing that's happened at this point is we've gotten rid of the 3s. So we still have absolute value x plus 7 less than or equal to 2. Okay, so then we're doing x plus 7 less than or equal to 2. On the left side, same symbol, so just on the other side of it. And then what number goes over here? -2. And then we're just going through the steps. Subtract 7. Subtract 7. So we got x in the middle, less than or equal to -5, greater than or equal to -9.
That is really hard to read, by the way.
Oh, well, the -7, let me make that a little bit easier. You see it now?
Thank you.
Okay.
Yeah, I can see it now.
All right, so is this algebraic or interval notation? Algebraic, it has a letter. So you'll have to pay attention to the directions. Sometimes they'll they'll just want interval. Sometimes they'll want algebraic. Sometimes they'll want both. So you just have to pay attention. But algebraic has a letter. They want interval. Sometimes they'll do algebraic interval and then they'll ask you for the graph. But I usually recommend that you do the graph and then interval. So got -9. We've got -5. Brackets or parentheses there? Brackets. X is greater, so those are going to be the things to the right of -9. X is less than -5, so those are the things to its left. So what's the first thing on the interval notation? The bracket first, and then -9. What's after the -9? Comma, and then -5 bracket. Okay, you guys got it. Okay, I've got 5 examples, so not very many more. Number 3, absolute value of x minus 3 greater than 9. So this one I want to really highlight. Whoop. So isolate. Okay, so always isolate the absolute value before you do anything else. On some of them, that's already done. So isolating absolute value, but if the absolute value is greater, and I'll say this sort of in basic terms, if that mouth is open towards the absolute value, then we do this a little bit differently. So, sorry, that's hard to read. If the mouth is open toward the absolute value, we split the inequality. And basically, I know that probably doesn't make any sense, but x minus 3 is greater than 9, just like it reads. And you might be tempted to put the same symbol on the left and then -9 over there, but we do this one a little bit differently. And by the way, let me show why this is. You don't have to write this part. Let me move this. So just keep in mind, if the mouth is open towards the absolute value, we're not doing it the same way. If you did, then we'd be saying that whatever that is in the middle is greater than 9, and it's also less than -9. So if you can try to think of a number that's greater than 9, but it's also less than -9, there's no number that exists like that. So, so this one we say x minus 3 is greater than 9, and then we have to do an or. X minus 3. So now we're doing the opposite symbol. And then what number do you think we're using? This won't come up a whole lot, but be sure that you notice it when it does. That mouth is open towards the absolute value sign. This is how we set it up. And then, because what's going to happen is, on the last ones that we did, we had some overlap. You know, there are some things that are greater than -9 and some things that are less than -5. So you've got some overlap there. On this one, there's going to be no overlap because there's no number that's greater than 9 and then also less than -9. We'll have 2 different sets. We'll have some things that are greater than 9, some things that, well, not 9 in this case, but so just solve these, add 3. X is greater than 12. So we'll have a set of things that are greater than 12. Over here, add 3. And we've got X is less than -6. So I just want to highlight those symbols again. So at first, when you set this up, it looks exactly like it does up there, except without the absolute value. Over here, swap it and then negative, or reverse it, negative rather. Okay, so if you're doing algebraic, these are your two answers. If you're doing interval, still have to make a number line, or yeah, number line. Which number would be left over here? -6, yeah, the smaller one's left, and then the 12 over here. Brackets or parentheses on these? Parentheses, we don't have the or equal to part, so we're gonna use parentheses. And you want the parentheses to face, so here we're saying X is greater than 12. So think of the things that are greater than 12, 13, 14, 15. We want the parentheses to face those things. So 13 would be here, 14. So the parentheses is gonna face that way. It's touching the 12 and then going that way. On the other one, we're saying X is less than -6. So -7, -8, all those things to the left. We want that parentheses to face that direction. So a couple new things here. When we're saying X is greater than 12, that goes up and up and up and up and up to infinity. On the other side, -6 goes down, down, and down. Any idea what this side's called? Negative infinity. And a little note here, always use parentheses at infinity or negative infinity. Always, because the bracket means you're including that number. If we're saying less than or equal to 5 and you put a bracket at 5, we're saying it could be 5. If you put a parentheses, we're saying it's not 12. Like it has to be greater than 12, so it can't be 12, even though it touches the 12 sort of line on the graph. Touches 12, but it's not 12. It's as close as conceptually possible to 12. So when you're doing the interval notation, it's gonna look like the graph. Interval notation looks like the graph. So you wanna start with the leftmost thing, which here is negative infinity. And we always use the parentheses at negative infinity because it can never be equal to negative infinity. Negative infinity is not a number, so it can never be equal to that. And then this goes all the way up to what? -6, close parentheses. So just like the graph, negative infinity to -6. And then we're gonna use a U because we're unifying this set and then the other set of answers. Infinity, and then what on the end here? Parentheses. All right. Hopefully that makes sense. And by the way, that U, you can't just type U from the, well, actually, I think you can't type U. You have to go to the keypad, and there's a U in there that you'll find. So I'll just put on keypad just in case. All right, two more. Number 4, we've got 11. 6 minus 3x and the absolute value -1. Okay, get absolute value by itself. So first step, add 1. Make sure you don't lose those absolute value symbols because we haven't eliminated that. Just got rid of the 1, the -1. And at this point, it's basically the same thing as before. If that mouth is open towards the absolute value symbol, then we need to put open toward absolute value. Use or. So we're gonna write it as is. 12 less than or equal to 6 minus 3x. Or negative 12, and then we're using a different, I'm kind of make this obnoxious. Okay, so a couple differences after the or. Using a different number, the opposite of 12, and then that. Okay, so mouth is open towards the absolute value symbol, we're doing or. Otherwise, we would have just done, if it were reversed and the mouth was open away, we'd say 12 is greater than or equal to 6 minus 3x. Same symbol on the other side, and then negative 12 on the right there. So trying to get the x by itself. Divide by negative 3. And one important point on this one. If we divide by a negative, like we are here, we're dividing by negative 3. It doesn't matter what the top number is. If the bottom number, the thing that we're dividing by is negative, reverse, I'll put this in capitals, reverse the symbol. So we've got negative 2, and then now that symbol reverses and we've got x on the right. So okay, divide negative 3 on both sides, negative 18 divided by negative 3, positive 6. Reverse that symbol. Okay, there's our algebraic notation. Got negative 2, we've got 6. So you want to think about those. The mouth is open away from x, so that means x is less than negative 2. We're using a bracket there. Using a bracket on this one. X is greater than or equal to 6. So all those things. So your graph will look like that. And then when we're doing the interval notation, what's the first thing that we've got? Yep, parenthesis, negative infinity, negative 2, bracket, u, and then bracket 6, comma, infinity. Let's see. Okay. I'm glad you guys seem to get this. This is the interval notation part, usually what trips people up a bit. Okay, one more. 3, and then y minus 2, absolute value symbol, plus 12 is less than 7. This one you won't see a lot of, and I'll kind of go through the steps fairly quick because you guys have seen this. So getting rid of the 12, 3, and then an absolute value y minus 2, less than negative 5. Divide 3. Still have the absolute value, y minus 2, less than negative 5/3. No solution. Yeah. Absolute value here is less than a negative. Can't be less than a negative. Absolute value cannot be less than, I'll just say a negative. Can't be less than 0. Definitely can't be less than a negative. So no solution. Okay, this is the last section. After this, I'm going to put the exit assignment on the board, and as soon as you guys turn that in, you're free to go.
I'm about to connect on my laptop.
Okay. The exit? Yeah, that's going to be on Canvas. What I'll actually do is I'll put a problem on the board. You'll write it down on paper, and then with the Canvas app, you'll take a photo of it and submit. I'll show you how to do that when we get there. Introduction to functions. Like I said, this is probably one of the easier sections that you'll see in all of college algebra, intermediate algebra. Number 1, relation. This is a little bit of vocabulary. Set of ordered. Set of ordered pairs of real numbers. Relation, set of ordered pairs of real numbers. Function, each first coordinate in a relation has a unique corresponding second coordinate. That doesn't necessarily have to make sense to you while you're writing it, but there's going to be some problems where they just want you to identify the definition that goes with the word. So as long as you have it written down, it should be pretty easy. And I'll explain some more about relations and functions here in just a bit. All right. One of the easier things that you'll have to do, does the graph represent a function? Does the graph represent a function? So I'll draw a few different graphs here. Does the graph represent a function? Okay, so we got 6 of them. Sort of a V, sort of a Z, a circle, straight line, and kind of a hill. Does the graph represent the function? We're just going to use the vertical line test, which basically means if you draw a vertical line, how many times does it hit it? If it hits it more than once, it's not a function. So if we drew a vertical line, it doesn't matter where you draw it on this first one, how many times would it hit it? Just once, so that one is a function. This one here? Yeah, it doesn't matter where you put that vertical line, it's only gonna hit that graph just once. This one here? No, because if you put it on the far end, just hits once, but if there's any spot, like if we put it right there, it would hit 1, 2, 3 spots. So this one's not a function. And let me write that out explicitly. If a vertical line hits more than once, not a function. So no on this one. What about the circle? No on that one. This one would only hit once. This one would only hit once. So out of those 6, only 2 of them were not functions. So not a function. So hopefully that's pretty easy. That'll come up also, I think, when you get to college algebra a bit. Okay. So hopefully everybody's good with spotting those pretty quickly. Domain and range. This is the only part of it that it's pretty intuitive once you get it, but sometimes it takes a minute. Domain is basically how far left to right. These are the X values. How far left to right. Domain, by contrast, is how low to high. These are the Y values. So domain, how far left to right. Range, how low to high. So if I go back to these ones, I'll do this. Let's see. Okay, so if we had let's say a Y-axis, we had an X-axis. I imagine you guys have seen the coordinate plane before. Y is the straight up and down one, X is the horizontal one. So for this graph, if we're doing the domain is how far left to right. So if we're just looking at the first graph, saying how far left does that go? It might look like it stops at, if we say this is -2, but that arrow up there tells us that it keeps going left. It's going up and left, but it keeps going left forever at a gradual pace. And then if we're thinking about how far right it goes, it keeps going right forever and ever and ever and ever. So on this one, so it goes left forever, it goes right forever. We'd say -infinity. This is the X values. It doesn't stop at -2. It goes to -3, -4, -5, -6, -infinity. And then to how far right does it go? It goes to infinity. And always parentheses at the infinities. And you can put the domain in like that, but -infinity to +infinity, that includes everything. So you'll have a little button here, all real numbers. You can either put in that interval notation with the parentheses, or you can just click all real numbers. The range, again, is low to high. How low does this go? What's that? -infinity, low, goes down, down, down. And then up, up, up to +infinity. So the same thing on this one. So you can click all real numbers on both of those. We'll go ahead and do the circle one. So the y-axis is a straight up and down one. X-axis is the horizontal one. So for the domain, we're saying how low does it go to how high does it go? Or let me say that back. We're saying how far left to right. So I'm gonna put a few things here. So I'm just gonna say some random things, -7, -2, 2, and then we'll call that 9. So domain, how far left does it go? -7 is the furthest left that it goes. It never gets to -8. What's the furthest right that it goes? 2. And for these ones, we're just going to assume on all these that it actually touches that line. So we're going to use brackets on everything except for the infinities. If it goes to infinity, we'll use a parentheses. Anything else, we're using a bracket.
Isn't it as far as -2, not 2?
Oh, -2. Thank you. And the range, you always have to do the lower number first. So the lower number left, the higher number right on the domain, range, lowest number first, and then the highest number. So the range, bracket or parentheses on this? Bracket, because the number's 2, and then the highest, 9. And using a bracket on that. On these ones, domain and range, we're only going to use parentheses on the infinities. Okay. Hopefully that's enough for you guys to catch it when it comes up on your examples. But I think that those are domain and range might be the only thing where you have to think for a second. Number 3. So I'm gonna put a few dots around here. We'll call this A. And by the way, that's 1, 2, 3, 4, 5, 6, 7 slashes down. Call this D. Call this C. And we'll call that B. Okay, so they're not gonna give you these. They'll ask you to list the ordered pairs. So you're always gonna do X first and then Y coordinates. The Y-axis, the X-axis. So you're gonna say, how far left or right are you going first? So if we do A, so the X on that, would that be, how far left do we have to go for A? -2. And then -7. Okay. Hopefully everybody's good with that. And then B, just doing the same thing. 6. And then -3. What's the X on C? And then is that 5? And by the way, not using brackets on these because we're just doing an ordered pair. We're saying this is what the point is. We're not saying from here to here. Hopefully that doesn't cause any confusion. But we're just saying this is how you get here to this point. D, -2. And then what's the second one? F2, yeah. Okay, so, and then domain on this is gonna be even easier. Domain, is that the X or the Y values? X values. So we just have to list the X values that we've got. We've got -2, 6, 2, and then you don't have to list the -2 again. I think they'll actually just give you boxes. They'll give you 3 boxes. So you'll know I don't need to repeat that second -2. And then the range. Range is the Y values. Function. Okay, so so for a function, you don't necessarily have to write this down. But this one here, did we say this was a function? Not a function. If you drew a vertical line, it would hit it twice. So basically, you'd have some X value. Maybe we call this 1, 2, 3, 4. Maybe we say 4. For 1, I'm just making this up. This one would be 4, we'll call it 10, something like that. So basically you've got one domain, one X value, 4, that has 2 different outputs. If you put in 4, you can get 1. If you put in 4, you might also get 10. So that makes it not a function. So as long as each X value has only one Y, yes. So if we look up here, it's gonna highlight our -2, because -2 shows up twice. -2 gives us an output of -7. -2 also gives us an output of 2. If you got an input that gives you 2 different outputs, it's not a function. So would this one be a function? So I hope this isn't too messy. Not a function. And just to clarify, because what was it, -2, -7, and -2. So it would, if you can imagine, I don't know what the shape of this function would be. Well, it's not really a shape, it's just a bunch of these. So basically, if you drew a vertical line, this is maybe an easier way to look at it. If you drew a vertical line here, you would hit it twice. If you drew a vertical line at C, you'd hit it once. Vertical line at B, you'd hit it once. But this proves it's not a function because you would hit it twice. Okay, hopefully that's easy to follow. And then the last thing, consider the function f of x equals -3x plus 6. And by the way, with function notation, that's how you read it. F of x. I know it looks like f times x, but f of x. And then we're asked to find the value of f of 4.2. Find the value of f of 4.2. So really simple. All we've got to do is substitute for each x. Sometimes you have multiple x's in there. Every one of those you're going to plug in a 4.2. Here there's just one x. Okay, I know I flew through that, but just plugged in instead of we had -3 times x plus 6. So really -3 times 4.2 plus 6. -3 times 4.2 is -12.6 plus 6. Okay, stop me if you need any clarification on anything. H of x equals -2x to the third plus 2x to the second plus 4x plus 3. We'll call this is really the second part of 4, but we'll call it 5. So h of x equals -2x to the third plus 2x squared plus 4x plus 3. Find the value of h of -1. Substitute for x. So -2, I'm putting in parentheses, -1 to the third plus 2 and then -1 to the second plus 4 times -1 plus 3. Just replacing each one of those x's up there. Make sure on these ones, do exponents first. You don't want to multiply the -2 and the -1 and then cube it. Do the cubing first, do the squaring first, and then multiply the 2 and the -2. So -1 times -1 times -1, -1, and then -1 times -1, 1, and then this one we could just do 4 times -1 is just -4. -2 times -1, 2 times 1. So basically have 4 minus 4, which is 0, plus 3. Okay, and then one more definition I should have written down. The set of all second coordinates, you guys could probably have figured this out anyway. The set of all second coordinates in a relation is so when you got a coordinate, you've got x and then y, right? The y's are the range. So the second coordinate in a relation is the range. Okay, and that'll come up just as a definition. You know, you'll have the set of all second coordinates in a relation is I think they'll have a blank and then a few different options. You just click range. Okay. All right, Trenda, you can do this also. I'm gonna put, I guess I'll write it on here. So on a sheet of paper, I'll have you guys write this out. And by the way, this is a problem from the study guide. So this is something that you're likely to see on the test. Hopefully it seems pretty easy. A lot of times the problems that end up on the module exam are the generic versions of the homework problems. So as long as you can hold on to the generic kind of, well, at least some of them. Some of them are a little bit harder, but a lot of them are fairly basic. Okay. So we'll call this exit 1. And before you guys get started, let me walk you through the process that you'll do. Okay, so in the, you can probably imagine this. In the app, click on assignments. It's underneath announcements. So assignments, and then you'll see exit 1 at the top. Click on that, and it'll look different for you guys because instructor, they show you something different. But you should see a submit, and then after you're done working this out on your paper, click submit. Hold this over your paper. Try to make sure that it's oriented right, because sometimes I get sideways ones. That's not a big problem, but I prefer it if it's, oriented right. Take a photo. Huh? Oh, it's Canvas. Yeah, you might download that if you haven't already done it. The Canvas app, and then you'll submit it, and you should get some confetti.
Where will I find that at? Under Hawks login?
No, it's an iPhone app or an Android app.
Right, I'm in Canvas.
No. I don't know if you can do this on the desktop version. Do you have the app on your phone? Oh, okay. Yeah, in the Canvas app, and you go into the class page, click assignments, and you should see exit 1 there. All right, so here it is.
On the website.
No. So find f of -2, and this is a problem that you'll see on the test. For f of x equals 9x plus 2. Make sure you show your work for full credit, since I always grade the work. As soon as you guys have submitted that, that's it for today. And just a little reminder, 7:10, 7:11, and then 8.5, all due Wednesday midnight. Well, I like this sitting down teaching a lesson. This is all right. I used to have back-to-back classes, and I'd have to be standing up for 5 or 6 hours. You wouldn't think that'd be tiring, but wow.
I'm gonna go upstairs, take a picture, and I'm gonna email it straight off, and then.
Is it not? It's not allowing you to do that?
Well, so, yeah.
Oh.
Sorry.
Well, how about this?
It doesn't work with the Wi-Fi.
Yeah,
so
there's
it's
no
a text code.
Oh, that's right. Well, how about this? You guys can just give me a piece of paper.
Oh, okay.
I've been doing it this way mainly because of COVID, but I think we're all right. Just a sheet. Submit it? Okay.
There you go.
All right. And another thing, I don't mind if you guys collaborate on any of these. I know this one's probably not too difficult, but if we do have one later on where you're unsure, you guys can say, hey, what'd you get?
Do you want me to take a picture anyways when I get home, just so it's in there?
No, you don't need to.
Are you sure?
I got this. And if it ends up showing up as a 0 on there, you can say, hey, remember I gave you the paper? And I'll say, I don't remember that. Sounds like a lie. Just kidding. So it didn't ask you for a number verification when you logged in? Well, when you're okay. When you log in, as long as you're already logged in, it's okay. Okay.
I've already logged in and all that, so I was able to submit it with the Wi-Fi.
All right, thank you. Nice meeting you guys. Hopefully I'll have your names down sometime next week. All right, you too.
Now, if I remember correctly, we're trying to find F, right?
Well, you're just trying to solve it. Did you get any of that the last couple examples we looked at?
Yeah, I've got that. And so the way that I like wrote it down was F parentheses -2 parentheses equals 9 parentheses -2 parentheses +2.
I didn't catch all that, but that sounded right.
Here, let me see if you can see it. Maybe.
Well, I'm not gonna tell you if it's right or wrong or not, but you started it right. Well, maybe you guys can log into the Canvas app before you come in next week, and maybe it'll work all right. If not, we can just do the paper thing. All these technical issues. I know. Huh?
What was that?
Yeah. Oh.
I'm so glad my kids are growing and out of that.
Did you guys have a regular graduation or did you do digital?
You got a set amount of tickets, and
Oh.
it wasn't normal, like the teachers were down there, they were more like in the audience.
Ah.
I don't think it's bad, because my sister now knows how to do everything online.
Yeah, it's.
Yeah, that's where it's
That's
going.
why I chose most of my classes online, but I suck at math, so I couldn't-
Yeah, math's probably one of the last ones you want to do
My
this way.
son did
I
his
think
senior
it's
year of
very
college
good.
last year.
Huh?
My son did his senior
Yeah,
year of college
I got it
online.
online and I dropped it.
He came home for spring break and
I
they
also
closed school
worked
and he was
so I
home.
had to do it online, and then-
So he had to finish the senior projects and thesis and all that stuff online. He says it was absolutely horrendous.
Yeah,
Especially
some
for
stuff
an
that you could.
Especially for an engineering degree.
Oh yeah.
It says it was the worst thing ever.
Wow, I can only imagine.
My niece is a chemistry major. She's like, how do you do chemistry? The labs, no, it was just
I don't know.
terrible.
Well, hopefully we're not going back to that. We took one step back with these masks now, so. Oh, wait. Is this one, did I get one? This is not yours, is it?
No, I sent mine, but I figured it out.
Okay, I think this is Lily's, maybe. Trenda, you doing all right?